Hey guys, welcome back to my classes. So today we are going to discuss like what is machine learning, features of machine learning. So let's start. So types of ML models. We do have two types. First is supervised learning, and the second one is unsupervised learning. So machine learning consists of multiple machine learning models or algorithms you can call. So most famous, very much used, are regression and logistic regression, and also classification, where we do binary class classification and multi-class classification. Here, if we see on the screen, it is clearly evident that there are two types of classes. One is spam and one is ham. So spam, everyone is know, spam mails where we receive in our email box. And we also have ham, where we need to classify spam and ham classes. If we use Gmail a lot, we know like what is the spam and what is ham. The updated all are clustered or classified before coming to our Gmail. So there are multiple classes like promotions and updates and multiple, like spam is also classified, and multiple things will happen in Gmail model classification. Also, we have Google Photos, where we classify based on the photos of persons. So this image classification or and all comes under convolutional neural networks. We'll be discussing in the future classes. So we already discussed that we have supervised and unsupervised learning. Let's first discuss like what is supervised learning. Supervised learning is labeled data. So what is labeled data? We'll be having a training data and test data which are labeled. Labeled means it is classified before. Like imagine there is a spam mail and there is a reasoning for n- that being spam, and ham mails there is a reasoning for that being ham. So this will be having the labels. The output variable or target variables are present in this supervised learning. So, in supervised learning, we have a model called linear regression, where we have input features and also output features. In input features, we'll be having multiple variables or features, where based on that we'll be reducing the dimensionality. Dimensionality, I'll be posting a short regarding what is dimensionality. So when we plot our data, we need to draw a line where we can see here, and it should pass through most of the data points. So that is what we our model should be. The ideal model is always uh, will always be a line which passes through most of the data points, and the mean model which passes not exactly the a better model, where we do have R1 score. We'll be discussing very soon what is R1 score, adjusted R1 score. So this is what exactly it is. So our we do call this line as uh, uh, y hat, which is nothing but prediction. So our model should be predicting as good as possible with a better score. That could be 90, 80%. It depends on the model building and the feature we have, data we do have. So more the data, better the model is. So we need to have a better thing. So here we can see like it is passing through most of the data points, and here we can see the red line is not passing through all the points, and there is a green line which is passing through most of the points. So we'll be discussing like what is this cross line, why this is not mm, diagonal. So that is what we'll be discussing very soon. So this is how the things work in the regression problem. So I hope you understood what is a regression model. So we'll be discussing classification next. So in supervised learning, we do have another model, which is logistic regression or classification. So there are multiple classifications, binary classification and multiple class classification. So right now we are going to discuss about classification which are labeled. So what is labeling or how you label a class in the model? So imagine we are plotting the data of all the fruits. So the fruits will be having a different measurements like the height of the fruit or the width of the fruit. Based on that, we'll be classifying the fruit. So imagine this or blue green color data points are grapes, and here we do have orange color uh, data points, which we will be considering as strawberries, and the blue color data points is considered as watermelon. So all three fruits will be having different dimensions like height or ratio or width and multiple things. So this based on this condition, this height and width and ratio can be considered as features. So using these features, we'll be classifying our data points. So we'll be teaching this using training data and testing the inference and getting the score. The well classified models, uh, the data will be the data is uh, uploaded to the model where it learns and tests and gives us the score which predicts the better score. So we'll be having a multiple metrics where accuracy and R1 score, precision, R1 score not here, precision, recall, F1 score, and AUROC and PRC. All this comes under the metrics where we do measure our model performance. So this is how we'll be classifying all the data points based on the features. So I hope this classification model is uh, well explained, and I hope you understood this. And yeah, this is all about classification. So I hope you guys liked my video. So please like, share, and subscribe to my channel. Thank you very much, and happy learning.